Do you ever wonder how printers and other devices can be attached with our PC or laptop? Kirchhoff's rule. Let us examine first the first rule of Kirchhoff. This is called Kirchhoff's node or the junction rule. Supposing there is a junction in a particular circuit. This is the junction right there. According to Kirchhoff's node or the junction rule, the sum of all the currents coming into a junction must equal to the sum of all the currents that are leaving the junction. For example, we have current 1 before the junction. Current 1 is leaving now the junction. Let us say there is another current, which is current 2, that is going to travel towards the junction at the same time will be leaving the junction. In this rule, it is stated that the sum of all currents coming into the junction must be equal to the sum of all the currents that are actually leaving the junction. So this is how it is illustrated in the formula. Kirchhoff's loop or circuit rule. According to Kirchhoff's loop or circuit rule, that the sum of all the voltages in the loop is equal to 0. This is a principle under the conservation of energy. Supposing a voltage, let us say this is V sub 4, and a resistor of resistance R1 will experience a voltage drop which is V1. Resistor 2 will have a voltage drop of V2, while the resistor 3 will also have a voltage drop of V3. Therefore, as the voltage and resistors are connected in circuit, we can compute for the sum of all the voltage and the voltage drop, so that V4 minus the voltage drop of V1 minus the voltage drop of V2 and the voltage drop of V3 should be equal to 0. And so V4 is the voltage potential, while V1, V2, and V3 are the voltage drops. So this is a problem where we can apply the principles of the Kirchhoff's node rule and the Kirchhoff's loop rule. You see that we have a closed circuit of a 7 ohm resistor that is connected to a node at A, and then we also have a 5 ohm resistor, and then there are voltages. We have the 6 volt, we also have the 4 volts and the 8 volts. In terms of current that is passing through the circuit, we have I1 coming from the 7 ohm resistor, and we also have I3 coming from the 4 volt, and then I2 coming from the 5 ohm resistor. And so we are going to find the currents in the circuit, and then the formula to be applied is the Kirchhoff's node rule, which is I1 plus I2 plus I3 is equal to 0. So we are going to isolate first the first loop, and you notice that there are two variables in here, I1 and I3. But we are going to apply the loop rule for this loop to solve for I1 and I3. However, the loop rule is applicable to the voltage in the loop, but by means of Ohm's law, we will be able to find for I. And so, the loop rule states that all of the voltages in a loop will equal to 0. And so the first volt that we have is 6 volts, and we also have 4 volts. So 6 volts plus 4 volts minus the voltage drop along the resistor with a resistance of 7 ohms. And according to Ohm's law, V is equal to IR. Thus, our R is 7 ohms, and that will be multiplied to I. So I1 will now be equal to 10 over 7. And for the second loop, we have 4 volts, we have 8 volts, current 3, current 2, and resistor, which is 5 ohms. And so we are going to apply the same principle as what we did in the first loop. So this is using or utilizing the loop rule, and that is adding the voltage, which is 4 volts plus 8 volts minus the voltage drop, which is given by the Ohm's law to solve for voltage drop, and that is I times R, where our resistance is 5 ohms times the current, which is current 2, and that should be equal to 0. Or eventually we will be able to solve for I2, and that is equal to 12 over 5, and that is how to solve I2 in amperes. Now going back to the original circuit, after the isolation of the two loops, we will now be able to solve for the current, because I1 is equal to 10 over 7. I2 is equal to 12 over 5. Now what about I3? How to solve for I3? Going back to the first Kirchhoff's node rule, I1 plus I2 plus I3 should be equal to 0. So we are going to substitute I1 and I2. Assuming that if we are going to transpose I1 and I2 to the other side, we will be able to solve for I3. And I3 is equal to negative I1 minus I2. And that should be equal to negative 10 over 7 minus 12 over 5, which is equal to negative 50 minus 84 over 35, and I3 should be equal to negative 3.8 amperes. So again, I1 is 10 over 7 amperes, I2 is equal to 12 over 5 amperes, and I3 is equal to 3.8 amperes.